In this video, we're going to be talking about object-oriented programming with regard to access modifiers. So in our part one of our video, we created a student object. Well, what's a student? Well, a student is these four class attributes packaged all together into a bundle that we call a student. Essentially, we're making a new kind of variable. So in our program, then, we can say student sum student is equal to new student, and that creates a name. It creates a student object and attaches the name to the object, right? Then we can say sum student dot first name is equal to Wendy. So the first name we have here is just part of the object, and so we're using the dot operator to access the first name part of the student object, right? And then we have system out print line. We have some student and we output their first name, and if I run this, we get Wendy, right there. Okay, so everything is looking good. Now, when we go over to the student object, we can see that the student has these class attributes. But typically, we don't really want other programs to access these attributes directly. And there's a number of reasons for it, but the primary reason is that we don't want other programs to mess with private attributes of other classes. We want other programs to have to make a request to change it. So, and the reason we want to do this is so that other programs don't haphazardly change the variable values into something that would either break the object or would cause some instability or some weird behavior. All right, so in order to do that, we introduce something called an access modifier. And an access modifier indicates which programs are allowed to access these variables. There are three access modifiers. Okay, so access modifiers, there is public. Okay, so when something is public, any program in any class can access this variable. So the default is public. All right, so I should write that. This is the default setting. All right, so because these do not have any access modifiers, they're automatically set to be public, which is why the main program over here has access to them. All right, aside from public, there's also private. So you have, when something is private, only this particular object can access its own variables. So here, if I set something to be private, okay, so I would say private string first name. Now, only Wendy can access her own private variables. So her first name, all of a sudden, is inaccessible to us, right? Because we are the main program, or this is the main program, and the main program does not have permission to access the private variables of the student. All right, so however, if I change this to last name, then all of a sudden this would be acceptable again, because the last name, being not labeled, is by default public, right? So that's how that works. Now, typically though, we declare all of these as private. Now, it's not always the case. You can make them public, but in general, they're all usually considered made to be private. And I should not have erased the variable type there. Okay, so we have private string first name, private string last name, private int grade, private double GPA. All right, now that creates an issue for us over here though, because now our variables are not accessible, right? So we have a first name. In fact, we've created the student Wendy, but none of the variables of Wendy are accessible. So essentially it's a useless variable. So how do we get access to these? Well, what we do is we generate something called a getter and a setter. Okay, so the real name is accessors and modifiers. Okay, but also known as, so AKA, getters and setters. For the most part, everyone refers to these as getters and setters, and no one really calls them accessors and modifiers that I know of anyways. All right, so let's say I wanted to access this first name. What I can do is I can actually create a method that would do that. The basics method always looks the same. Okay, so for a getter, okay, we're going to get this thing. Okay, so we're going to say public. So we're going to set the access modifier of this method to be public, because if it's not public, then we wouldn't be able to call it, right? So because we wouldn't have access to it. So we're going to say public, and then we are going to create the return type, so string, so public string, and the name would be get first name. This is the standard way that it's written. So if the variable's name is last name, then it would be get last name. The getter for the grade would be get grade. All right, so we have public string, get first name, and typically we don't have any parameters or anything like that. All right, so, and all we do here is we say return first name, like that. All right, so going over here, back to our main program, we are not allowed to access the first name variable directly because it's private. However, we can say get first name like this as a method and ask the object to return it to us. Right? And so in this case, you see the red line disappeared and we are able to do this. However, because it's still private, we can't set it to be Wendy. So we have to go over here and we have to create a setter. Okay, a setter looks like this: public void, okay, typically set first name. Now, in order to set the first name, we have to know what the new name is going to be. So what I'm going to do is I'm going to say string new name. All right, and then what we can do is we can say first name is equal to the new name. Okay, so the first name, which is this class variable up here, is going to be the new name that's provided as a parameter or as an argument. Okay, so instead of saying some student dot first name Wendy, we would say some student dot set first name, and we would provide the Wendy as an argument to the method. Okay, like so. So instead of accessing the method directly, or the variable directly, we use a method to call it indirectly. Okay, so we have get first name, and it just returns the first name. We have set first name, and we provided a new name, and then we just say first name is equal to the new name. Now, that brings me to something that a lot of students generally don't like at the beginning when they first learn this. It is a little bit confusing. Now, typically, whenever we're writing these getters and setters, we typically don't use, like, say, string new name. Instead, we would say something like this: string first name. All right. Now, the problem is, because this new name variable doesn't exist, we'd also have to call this first name. But now we have a code that says first name equals first name, which is essentially saying A is equal to A. Right? So what is this all about? How do we make this work? Right? So the important thing to understand is how many variables there are here. Okay, so let's only consider the first name variable. Well, how many are there? Well, there's one that belongs to the class, that's here, and there's also one that belongs to the method. So there's actually two different variables called first name. So how do you distinguish between the method first name and the class first name? Okay, so the method first name is this one, and the class first name is this one. So how do you distinguish them? Well, what we do is we use a command called this. All right, and what this does is it gives a reference to itself. Right, so when I point at an object and I say this thing, I'm talking about that particular instance of that thing. And so when I say this, I'm talking about, it means the class, the object. So this object's first name is equal to first name, which is the first name in the method. I know it is a little bit confusing, but that's essentially how it works. Right? I showed you guys earlier in video number 1 what would happen if I said sysout some student. Okay, so what would happen if I just output this variable? Well, it should give the memory address for that. Okay, so we have code student, and it's at this memory address. Right, so then what I could do is I could just make another public Okay, so what I'm going to do is I'm going to make a variable, a method that just returns the student itself. Okay, so student, and we'll say get student like this. And all this does is just return this. Okay, so it just returns this. All right, and over here, I will also call sysout get student like this, or it would be some student dot get student. Okay, like so. Okay, so some student dot get student, and I can't type today. All right, and what we should see is that they should have the same memory address, right? And as you see, they have the same memory address, right? Because some student was created in the main program and it's assigned to this memory 3682339C8. And then we go to the student and we say return yourself, right? So this means yourself. So it's returning yourself. So when it returns itself, right, it's printing the main program, then prints the memory location of that self. And it's, of course, in the same memory location. So when we go over here, we would never really do that. When we go over here, we would just say this first name. It means yourself's first name, right, is equal to the first name parameter that's provided in the method here. Okay, that's what we do for public and private and how we set these access modifiers to getters and setters. Now, typically, we have to write getters and setters for every single variable in the class. Right? And this can be a real pain because you could have many, many variables in the class. Luckily, Eclipse has a nice feature where you can just go like this and say source, generate getters and setters, and select the ones that you want. Now, if you notice, the first name getter is not available, right? Because we already wrote it. Okay, so I'm just going to select all and choose generate. And there's all my getters and setters. And you can see it follows the same format. So the get last name is public string get last name, or get first name, public string get last name, right? Public void set last name, and this last name is equal to last name. Now, an interesting one that some people will notice is that the GPA doesn't say this GPA equals GPA. And the reason why is because here I did not actually follow the proper naming conventions, and I used a capital letter to count the G, and it technically should be a lowercase g. So when Java generated the getter and setters, it followed the camel case convention, and it set it to have a lowercase g over here. But because this has a lowercase g, there's no need to distinguish between the two variables because the GPA, capital G GPA, obviously belongs from this one here, and the lowercase g GPA is this one here, right? But however, if I did rename this to lowercase g, then again, I would have to say this GPA is equal to GPA to indicate that it's the one from the class. All right, so that's how we create those access modifiers, and now we can access everything from the object. Now, sometimes students will ask, well, what's the point of setting all the class attributes to be private? So you're saying, hey, you know what? I want to protect my attributes, so I'm not going to share them with other people. But then I create these public getters and setters that just let me change it however I want, right? So why do we do that? Doesn't that defeat the purpose? Well, it actually doesn't. Okay, and I'll show you an example of why. Let's say, for instance, we have this set grade. Right? So this is the grade that the student is in. So let's say it goes from grade 1 to grade 13. All right, or this typical high school is 1 to 12. All right, so what I would do is I would say if the grade is greater than or equal to 1 and the grade is less than or equal to 12, then set the grade. And I don't need an else statement. I can just ignore it. All right, so let's go take a look at our program here. And so I'm going to create a new student. I'm going to name that student Wendy. But I'll say some student dot, so some student dot set grade Let's say we set the grade to be 12. And then what I will do is I'll print their first name, and I'll say some student dot get grade, like this, and we'll just print it out. And it should say Wendy 12. Okay, there's an error somewhere. System of print line, some student dot get grade, and there's an extra parentheses. There we go, Wendy 12. However, let's say I repeated this line, and I try and set the grade to be, I don't know, 20. Well, is this going to say 12 or 20? Well, it's still going to say 12. All right, and that's why we do this. Okay, why we set the access modifiers, because it allows the object to protect itself. If you try and change the values to something that wouldn't work for that object, the object just will reject the change. It just says, I'm not going to do that. It doesn't make sense, right? So for instance, if you had some operation that required some entering of a denominator, then you would reject it if it was 0, because it would break the program because you'd get a division by 0 error, right? So there's lots of examples here where you wouldn't allow students, or you wouldn't allow other coders to use the object in a certain way. And so this way the object can protect itself by limiting what kind of things you can change things to. Similarly, I could also, for instance, make the program lie. So I could say, for instance, like get grade, and I could say if, let's say, the grade is less than 50%. So let's not use, this is a wrong variable, it's GPA. So GPA goes from 0 to 4. So what I could do is I could say something like this for the getter. And I could say something like this. If the GPA is less than 2, meaning the student is failing, right? Then, and I'll generate a random chance. So I'll say and math.random is less than 0.5. So that's about a 50% chance. Then return A2. Okay, otherwise return just the regular GPA. And that's a little bit weird, but let's go take a look at this program now. So I'm going to go and set the GPA. So I'm going to say some student dot set GPA, and I'll set it to be 1.3. Now this is a D plus GPA. I'm hoping you never have a GPA like this, but let's do sysout some student dot get GPA. Okay, so I'm going to go and get that GPA from the student, and we'll see what happens here. So here we had a 1.3. Oh wait, I didn't change the program, but now we got a 2. Okay, back to 1.3, 1.3, 1.3, 1.3. Oh, back to 2. What happened? Well, what happened is 50% of the time when the student is failing, it tells you it's passing anyways. So essentially it lies about its marks. Now, this is just a whimsical example, right, to show you about how this could work, right, and how you could change the different behaviors of the object, but it doesn't necessarily have to do what you told it to do, right? It can do its own thing in its own way, right? And that's one of the beautiful things and the powerful things about object-oriented programming. All right, that is essentially it for the access modifiers. Stay tuned for the next video. In the next video, we're going to talk about the constructor.